Dear learners, warm greetings. I'm Dr. A. Jagata Christie, Assistant Professor of Physics, Jayaraj Hannapakyam College for Women, Perikulam. Today, we'll be discussing streamline and turbulent flow and wave motions. So let's get into the session. Before getting into the streamline and turbulent flow, we should have the basic knowledge of fluid dynamics. So to know into the fluid dynamics, we should know the terms of flow and dynamics. So flow is nothing but the movement or motion of a substance that can deform under applied force. And dynamics is nothing but a flow patterns, velocity profile, and pressure distribution within fluids as they move through open channels, pipes, and open spaces. Types of fluid flow. There are various types of fluid flows, including steady and unsteady flow, uniform and non-uniform flow, streamline and turbulent flow, compressible and incompressible flow, rotational and irrotational flow, 1, 2, and 3-dimensional flows. Today, we are going to see exclusively the streamline laminar flow and the turbulent flow. So streamline flow is nothing but the flow of particles of the fluid which follows a smooth path, where paths which never interfere with one another. So velocity of the liquid is constant at any point of the liquid. For example, water from the tap. So if you are measuring the velocity of the water inside the tap, it is constant at any point. And other examples are blood flows in veins, water fountains, water flow in rivers, and flow in water balloons. Turbulent flow. Turbulent flow is nothing but it's the fluid that undergoes irregular fluctuations or mixing due to change in pressure or velocity. It is random disruptive flow with complex calculations. In one simple term, we can say that it is completely opposite to that of the streamline flow. And the examples are blood flow in arteries in heart and air flow from the fan, oil transport in pipelines, and lava flow from volcano and ocean currents. The common example which explains the laminar flow and the turbulent flow is nothing but the water discharge from the tap to the sink. So through the tap, it is coming under a constant velocity, and which is nothing but the laminar flow. And when it is hitting on the sink, it is just going on a turbulent motion, which is nothing but the turbulent flow and getting into the sink. There are basic differences of streamline flow and turbulent flow. In terms of flow, particles, energy, kinetic energy, frictional force, and pressure. So usually streamline flow will be very smooth and orderly, and turbulent flow is completely opposite to that of that, which is a chaotic and unpredictable one. And particles move in a parallel manner for streamline flow, and it move in random manner for turbulent one. And minimum energy is dissipated for streamline, and significant energy is dissipated for turbulent. Kinetic energy transferred in the direction of the flow of streamline, and whereas kinetic energy transferred in all directions for turbulent flow. And frictional force and pressure is very low for streamline, and it is very high for turbulent flow. Reynolds number, which is one of the very basic characteristics of the flows, that is your streamline flow and the turbulent flow. It is the ratio of inertial forces to viscous forces within the liquid that is subjected to relative internal movement due to different fluid velocities. So as we see in the figure, the Reynolds number is different for the laminar flow and turbulent flow. So as we know, laminar flow in turbulent flow, or they are completely opposite to each other. So in the same way, Reynolds number also very lower for laminar flow, which is less than 2000, and above than 2000 it considered as turbulent flow. So it is indicated by the formula Re is equal to rho VL divided by mu, where rho is the density of the fluid, L is the characterizing length in the flow system, V is the velocity of the flow, and mu is the viscosity of the liquid. So defining the characteristics of streamline flow and the turbulent flow in terms of Reynolds number, obviously velocity, diameter, and stress are the important factor we have to discuss in this regard. So as we all know, streamline flow comes when it is less than 2000 Reynolds number, and it is having fluids with high velocity experienced in pipes with low diameter, such as our house line taps, and it lies in the viscosity of the liquid, which is having very low stress. And whereas turbulent flow, we know that is, it is greater than 2000 for Reynolds number, and the velocity is having, it is experiencing high velocity, and turbulent flow experienced in pipes with large diameters, and it depends on the density of the liquid. Boundary layers, which is a very important characteristics for your streamline and turbulent flow. So boundary layer is nothing but the thin layer of fluid in the immediate vicinity of the bounding surface formed by the flow of fluid along the surface. So there are two types of boundaries, laminar boundary and turbulent boundary. So laminar boundary is the boundary when the layers move smooth and glide over the side layers, and turbulent boundary is nothing but flow of layers keep mixing, that is, it contains swirls and eddies. Like in the washing machine, when we are just discharging water, it is going through the turbulent boundary, and in laminar boundary, it's nothing but the water coming out of the tap. Next, we are going to discuss about the wave motion. So wave motion is nothing but the propagation of disturbances, that is the deviation from the state of rest or equilibrium from place to place in a regular and an organized way. So the wave, we have experienced different types of wave motions. We can see waves in water. Like when you are throwing a stone inside the pond, you can see the circles form, which is nothing but the waves found in the water, and the sound waves and the light waves, electromagnetic spectrum we have seen, and motion of the subatomic particles. So mechanical waves, it is nothing but it requires a medium, for example, solids, liquids, or gas to propagate. That is the perfect example of transverse waves and longitudinal waves. That is, you are throwing a stone inside the pond, obviously it comes under the mechanical waves. And electromagnetic waves. Electromagnetic waves, they don't require any medium and propagate through vacuum. For example, visible light, radio waves, microwaves, infrared waves, ultrasound, X-rays, and gamma rays, which is nothing but the wave you are receiving from the sun. The whole electromagnetic spectrum comes under electromagnetic waves. And the next one is matter waves. Matter waves associated with the behavior of the subatomic particles. So the electrons and protons, the waves they are producing is called as matter waves. These are the basic characteristics of wave thing. Every wave can be explained in terms of their amplitude, wavelength, frequency, propagation direction, and speed. So amplitude is nothing but the maximum displacement of the height of the wave from its equilibrium position, whereas wavelength, which is indicated by the letter lambda, it indicates the distance between the two consecutive points that are in phase. Frequency shows the number of wave cycles passing a point per unit time, and propagation direction is nothing but the direction in which the wave travels, and speed is the rate at which the wave travels through the medium. And the picture shown below explains you what is the wavelength and what is the amplitude, what is the time factor, and how one oscillation is being calculated. And the wave used to behave in various factors, like the transmission wave, it just going exactly through the medium, and reflection, refraction, diffraction, absorption, and scattering. These are the behaviors of the wave. Applications of wave motion. So wave motions are very much useful in communication using radio, microwave, and optical waves, and medical imaging with X-rays and ultrasound, seismic studies to understand Earth's interior, especially when the earthquake comes, and sound engineering for music and speech production, remote sensing through radar and LIDAR technologies. So I think we have discussed clearly the streamline and turbulent motion and wave motion. So I thank everyone for your patience listening. Hope this session helps you very much helpful, and see you in the next session. Thank you.